So we are going to see Hamming code. Hamming code is the method in which you can detect or you can correct a single bit error, right? For an example, let me tell you, if you are sending a information that is 10110, all right, if this is what is the information you are going to transmit, in that message, if there is an error of a single bit, okay, if there is an error of a single bit, then you can correct that error by using Hamming code. How to correct the single bit error we are going to study today. All right, everybody understand what is Hamming code and where we are going to use it? While transmitting data, if you have a single bit error, then you can correct that single bit error by using Hamming code. Simple as that. All right, now see how to correct the information or single bit error by using Hamming code. See here, in Hamming code, we are going to use the concept of parity, right? Everybody is aware of what is parity, even parity, odd parity. Just reply me quickly.
एक्सप्लेन करा मैम एकदा. नाही मॅम. नाही मॅम.
माहित नाही parity म्हणजे काय. Okay, so there is a, I'll explain that parity later on. Just try to remember there are two different types of bits we are going to have in the Hamming code. First one is your message bit, second one is your parity bit. I'll explain this parity bit later on, right? Now, message bit is what? This is what is the data you want to transmit. See, I'll write it here. 1011. We'll take simple data. 1011. 4-bit data we are going to transmit, right? Now, we have to we have 4-bit data, 1 2 3 4. M is what? Your message bit. How many message bit we have? 4, right? Now we have to add parity bit to that. Now how many number of parity bits am I going to add into that, right? So this is the formula you need to remember. This is very important formula which will tell you how many number of parity bits you have to add. Okay, see here, 2 raised to p. What is p? P is nothing but your parity bit. 2 raised to p should be always greater than or equal to p plus m plus 1. What is p again? It is parity bit. What is m? Message bit. All right. Everybody understand the formula? What is the formula? Why we are using this formula? This is for how to, like, we have to know number of parity bits. Correct? Number of message bits we already have, that is 4. But now we want to know how many number of parity bits we are going to add into that. For that, we are going to use this formula. All right. Now see, if I put p is equal to 0. See, if I put p is equal to 0, what will be this? 2 raised to 0 is, if I put p is equal to 0, what will be 2 raised to 0?
1.
1. See here, 2 raised to 0 is 1. 1 is greater than or equal to, what is p? 1. What is message bit? 4. And this one, 4 plus 1 plus 5. Is this condition true? 1, is the 1 greater than or equal to 5?
No.
No. So we cannot use p is equal to 0. You understand what I'm trying to tell? Initially, we took p is equal to 0. Why? Because we want to know what is the value of p. Right? We want to know how many number of parity bits we are going to add into that. Randomly, तर तुम्ही bit select करणार नाही. So I will go sequentially, right? After that, I will take p is equal to 1. Now what will happen? 2 raised to 1 is
2.
See, now is the 2 is greater than or equal to 2 plus 4 plus 1? How much it is?
5. Sorry, 6.
7. It is 4 plus 2, 6 plus this one, 7. Is this condition true?
P1 है ना?
Okay, p we are
2 raised to 1, 2.
okay. It is 6. Anyway, still this condition is not going to satisfy. Am I right? 2 is not greater than or 2 is not equal to 6. Again, we cannot consider p is equal to 1. Similarly, I will go for p is equal to 2. Okay, what is 2 raised to 2?
4.
4.
4.
Now check 4 plus 4 plus 1. How much it is?
9.
9. Is this condition true?
Ma'am, parity bit 2 consider केलंय ना?
Yeah, ma'am.
Parity bit
7
2.
होते ma'am.
Okay, 4 plus 2 plus 1. This is 7. I'm sorry. All right. Is this condition true?
No, ma'am.
No ma'am.
So we cannot consider p is equal to 2. Now see, I'll consider p is equal to 3. What is 2 raised to 3?
8.
8. And what is the next calculation? 3 plus 4 plus
8.
1. 8. Now here we are going to get satisfy at least equal to criteria. 8 is equal to 8. This is correct. Am I right?
Yes, ma'am.
Whenever we take p is equal to 3, this criteria or this formula is verified. That is why I will consider p is equal to 3. You have to satisfy at least equal to condition. All right. Everybody understand this formula and this calculation what we did here?
Yes, ma'am.
Right. You have to satisfy 2 raised to p greater than or equal to p plus m plus 1. P is nothing but your parity bit, m is your message bit. Understand how we get p is equal to 3? Or should I repeat?
No, ma'am.
Okay. Let's move further. In the next thing, what we are going to see. Now we get to know our message bit. How many message bits we have? See here. 1011. This is what is the data we are going to transmit. We are going to take a simple example. 1011. How many message bits we have? 1, 2, 3, 4. See, 4 number of message bits we have. How many parity bits we get? P is equal to 3. We just calculated P is equal to 3, right? Message bits 4, parity bits 3. The total information we are going to transmit is now equal to 7 bit. 4 plus 3, 7. So the data which we are going to transmit, that is equal to 4 bit information, right? Now in this, where to add this 3 bits of parity? We have entire 7 digits, right? Out of 7, 4 are your message, remaining are your parity bits. Now on which position we are going to add that parity bits is the question. Now see here, where to add parity bits is your next and most important point. If whenever, like once you know the position of parity bits, it will be easy to calculate, right? Now see, this is nothing but your bit position. What is the bit position? 1, 2, 3, 4, 5, 6, 7. Why I write 7 only? Because total number of bits I have 7. Correct? You understand? How many number of bits we have total? 4 plus 3 is equal to 7. That is why I wrote bit positions from 1 to 7. Everybody is clear with this? Bit positions.
Yes, ma'am.
Why 7? Because message bit is of 4 digits and parity we have 3. 4 plus 3 is equal to 7. That is why 1 to 7. Now, we are going to add parity to the 2 power places. Okay, where we are going to add parity bit to the 2 power places. What is the meaning of this 2 power place? Is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. Okay, this is nothing but your 2 power places. What is 2 raised to 0?
1.
1. What is 2 raised to 1?
2.
2. 2 raised to 2?
4.
4. 2 raised to 3? Here consider there is 2 raised to 3. It will be 8.
8.
And so on. Correct. Now, in the given data, wherever there is 1, we are going to add our first parity. See here, this is the one I have. This is 2 raised to 0 place. And here I am going to add my first parity bit. Okay. The second 2 power place is 2 raised to 1. That is 2. Okay. This is 2. So I will add my second parity bit here. Now see carefully. Third bit is 3. But 3 is not the number which comes in the 2 power place. Correct? The next 2 power place is 4. Right? So here at the position of 4, I will write my third parity bit. Understand or no? Can I repeat? परत सांगू का एकदा काय केलंय? हे खूप इम्पॉर्टंट आहे. Once you know this, you will be able to solve Hamming code easily. Yes? Should I repeat?
Yes, ma'am.
Okay. Now the thing is, इथपर्यंत सगळ्यांना समजले how the 7 bits are, like from where the 7 bits are come? 4 message bit, 3 parity bits. 3 कुठून आणले parity bits? We use simply this formula, 2 raised to p is greater than or equal to p plus m plus 1. Message bits are already given, these are 4. By solving or by equating this two sides of the equation, we get p is equal to 3. 4 message bits, 3 parity bits. Total number of data is equal to of 7 bits. Now, where to add parity bits in that 7 bit, right? Initially, I just wrote down the bit positions 1, 2, 3, 4, 5, 6, 7. Because I have maximum 7 bits in the information. That is why I wrote bit positions from 1 to 7. Now, or at which place I am going to add the parity? The parity should add at the position of 2 power place. What is 2 power place? 2 raised to 0 is 1. Ithe 1 hai, mama, I will add my first parity bit. 2 raised to 1 is 2. So here I will add second parity bit. 2 raised to 2 is 4. Okay, so here I will add my third parity bit, not here. Getting what I'm trying to tell? We are going to add parity bits to the 2 power places. 2 power places, 1, 2, 4. Next, 2 raised to 3 is how much? 8. But we don't have 8 in the bit position, right? So that is why we will go till 2 raised to 2, that is 4. And here also we have only 3 parity bits. So 1, 2, 3. We are done with this, right? समझला?
Oh, ma'am. Yes, ma'am.
Shall we move? Okay, now see. First is what? Your parity bit. This is what is your 7 bit of data. From that, first is your parity bit. So P1 I will write here. Second is your second parity bit, that is P2. Now, this is the one position I have left with. Second position, third and fourth. Here what I'm going to do, I will add my message bits. M1, M2, M3, M4. See, this is what is written here. P1, P2. First I have 2 parity bits. P1, P2. After that, M1 is there. After that, P3 is there. After that, M2, M3, M4. This is what is nothing but your entire 7 bit of data, which you are going to transmit. Understand? हा entire 7 bitचा डेटा, त्यामध्ये पोझिशन, पॅरिटी बिटची पोझिशन आणि मेसेज बिटची पोझिशन. क्लिअर टिल दिस?
Yes, ma'am.
नाही समजलं? 4 मार्काला विचारतात हॅमिंग कोड. नसेल समजलं ना तर लगेच विचारा. खूप इझी आहे. तुम्ही अजून 1 ते 2 एक्झाम्पल सॉल्व्ह करा. यू विल बी एबल टू लाईक इझिली सॉल्व्ह द हॅमिंग कोड. समजलंय? की रिपीट करू परत?
मॅम पॅरिटी बिट 3 असतात का?
पॅरिटी बिट 3 कुठून
म्हणजे
आले?
आपण
आपण हा
three
फॉर्म्युला
दिला
बघितला
ना.
की नाही? जर माझे मेसेज बिट जर अजून 6 असते, ओके, इफ द मेसेज बिट्स आर इक्वल टू 6, पॅरिटी माझी चेंज झाली असती, बिकॉज आय हॅव टू सॅटिस्फाय दिस फॉर्म्युला. यू गेटिंग? जर आता सपोज कन्सिडर एन एक्झाम्पल फॉर पॅरिटी मेसेज, 6 बिटचा मेसेज आहे तुमच्याकडे, ठीक आहे. आय विल एक्सप्लेन दिस फॉर मेसेज बिट इक्वल टू 6, म्हणजे तुमच्या लक्षात येईल. If the message bits are equal to 6, what we are going to do? See here, 2 raised to 3, how much it is?
8.
8. Is the 8 is greater than or equal to? We have to check. How many parity bits we are going to add? We don't. 3 parity bits we added here. What is the message bit? Message bit is of 6 digits, right? Plus 1. 6 plus 3 plus 1. Is the signal is the criteria satisfying? No. Right? 6 plus 4, 10. So this we cannot use parity is equal to 3. Parity 3 we cannot use. Now we have to check for parity bit is equal to 4. If we put parity is equal to 4, what will be the calculation? 2 raised to 4 is how much?
16.
Right? Now here we have 4. Now this is 6 plus 4, 10 plus 1. How much it is? 11.
11.
This is satisfying my condition, right? 16 is greater than 11, right? we have to satisfy at least one criteria from this, either equal to or greater than. Right? Now here I'm able to satisfy greater than condition. 16 is greater than 11. Right? So that is why I will use parity is equal to 4 in this case. समजलं काय केलं आपण की नाही समजलं? शुड आय रिपीट इट अगेन? नसलं समजलं तर यू कॅन ऑलवेज आस्क मी. असं काही नाही की मी 4 वेळा सांगितलं तरी तुम्हाला नाही समजते, मग 5व्यांदा कसं विचारू? यू कॅन आस्क. समजलंय का खरंच?
परत सांगा मॅडम.
हम्म?
परत सांगा.
दोन्हीपैकी एक जरी कंडिशन सॅटिस्फाय झाली तर झालं ना मॅम?
हो, कुठली पैकी आता 2 कंडिशन आहे की नाही, आयदर ग्रेटर दॅन ऑर इक्वल टू. आपल्या मागाच्या when we consider parity bit message bit equal to 4, in that case we satisfy condition equal to. बरोबर? Now in this case when we consider message bit equal to 6, we satisfy the condition greater than. Either we have to prove one condition, greater than or equal to. All right?
येस मॅम.
Now clear?
येस.
Now see. सगळ्यांना समजलंय का? मला परत एकदा सगळ्यांनी सांगा बरं. Is there any problem to anybody?
परत सांगा
Because
मॅडम.
this is important. हा? मोठीच काहीतरी
परत
बोलतो,
सांगा.
मला कळत पण नाही काय म्हणताय. परत सांगू? कुठपासून परत सांगायचं? हे समजलं का? हाऊ वी अचीव पॅरिटी? काय काय?
फॉर्म्युला आहे ना आत्ताचा हा, तर त्याचा यूज काय म्हणजे?
अरे, how we are going to know the parity bits? By using the same formula only. If the formula is not present, how will we be able to identify number of parity bits? Is it? We are using this formula just to know how many number of parity bits we are going to use in the given information. Yes or no?
Yes, sir.
See, information is given to you. It's just that message signal is provided to you. Okay, how many number of message bits are there in the given signal? It is the just information which is given to you, right? Consider an example. We just saw the example of 4-bit of message signal is there, right? In that 4-bit of message, how many number of parity bits we are going to add? This is what is the question, right? And to know the number of parity bits, we are using this formula, 2 raised to p, that should be greater than or equal to p plus m plus 1, where p is nothing but your parity bit and m is nothing but your message bit. Simple. Yes or no? Why we
Yes,
use
ma'am.
that formula? The answer to this, to know the number of parity bits.
Okay.
Okay, try to understand the thing. Okay, I'll repeat the entire example from the beginning. Don't get confused. Let me erase this so that we can just start from beginning. All right. There are many people who are confused, I guess. Now see, Hamming code is what? It is the error correcting code. See here, it is written as it is an error correcting code. It is going to correct a error. But the limitation of Hamming code is it is used to correct a single bit error only. Right? Now, in that we have 2 different bits. One is your message bit, second is your parity bit. Okay. Now, in case of this, we will just consider simple example which have 1011. This is what is your message. तुम्हाला हा message transmit करायचा, right? What is the message? 1011. How many bits the message contains? 4. Right? So my message bits equal to 4. Clear the first point? From where the message bits equal to 4 this come from? Right? Now what we have to do? We have to identify the number of parity bits. Correct? How many number of parity bits we are going to add to this? To know that we are using this formula. Correct? Now see, just verify the formula. If I put p is equal to 2, will the condition satisfy? No, we just saw, right? The calculation which we did. If I put p is equal to 2, see what will happen? Just tell me. If I put p is equal to 2, 2 raised to 2, how much? 4. 4. Now this is what? 2. This is what 4 and this is 1. This is 4 plus 1 5 plus 2 7. Is the condition is satisfying either one of them? Is the 4 is greater than or equal to 7?
No, ma'am.
No. So we cannot use p is equal to 2. Right? I will move to next. If I consider p is equal to 3. What is p 2 raised to 3?
8.
8. Now see, 8 is greater than or equal to, here I have 3. 3 plus 4, 7 plus 1, 8. I get 8 here, right? 8 is equal to 8. I am satisfying either one of the condition. 8 is equal to 8, right? So this formula is satisfied here. Everyone is getting or no?
Yes, ma'am.
Yes,
Right?
ma'am.
Now that is why I can consider my parity bits is equal to 3. Message bit equal to 4, this is given to you, and parity bits we calculated is equal to 3. Now बोला, कोणाला काय होतं डाऊट आता?
मॅम पॅरिटी बीट म्हणजे नंबर ऑफ वन्स असतात ना, मग आपण डायरेक्ट ते तुम्ही 1 0 1 1 लिहिले त्यामधनं डायरेक्ट 1 कॅल्क्युलेट करून पॅरिटी 2⁻³ लिहिली तर डायरेक्ट
नाही
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 का?
असं नसतं, असं नसतं. सपोज दिस इन्फॉर्मेशन, आता सपोज असं सिग्नल असेल 0 0 1 1. आता याची पॅरिटी किती आहे? याच्यामध्ये किती पॅरिटी बिट ऍड करणार? कसं आयडेंटिफाय करणार? जस्ट बाय नोईंग दिस. तू इथे म्हटली की नंबर ऑफ वन्स 3 आहेत म्हणून मी इथे पॅरिटी बिट 3 घेतले, पण हा पण डेटा 4 बिटचाच आहे. याच्यामध्ये नंबर ऑफ वन्स 2 आहेत, सो आय कॅनॉट टेक पॅरिटी बिट इज इक्वल टू 2. Okay, just hold on. I'll explain the concept of even and odd parity first. म्हणजे तुम्हाला समजेल. खूप सारे लोक कन्फ्युज आहे अजून. पॅरिटी काय? सी हिअर. सी, इवन अँड ऑड पॅरिटी म्हणजे काय? आता पहिली गोष्ट, इन अ गिवन डेटा नंबर ऑफ वन्स. आता सपोज 0 1 1 0 हा तुमच्याकडे डेटा आहे. याच्यामध्ये नंबर ऑफ वन्स किती आहेत? कोणी सांगेल का मला? हाऊ मेनी नंबर ऑफ वन्स आर देयर?
2.
बरोबर. 2 इवन नंबर की ऑड नंबर आहे?
इवन
इवन नंबर आहे, बरोबर. दॅट इज वाय पॅरिटी ऑफ दिस group this digits is even parity. Okay, now see, just tell me this 0 1 1 1. How many number of ones are there?
3.
3 even number ki odd number hai?
Odd.
Odd. That is why parity of this is odd. See here, 1 0 1 1 kiti number hai त्याच्यामध्ये? How many number of ones are there?
3.
3 is odd number, that is why parity of this is odd. How many number of ones are there?
5.
5 is again odd number, that is why parity of this is odd, right? See this these examples. 1 1 0 0, number of ones is equal to
2.
2 is even number. Here how many number of ones are there?
4.
4 is again even number, that is why parity of both of them is equal to even parity, right? You cannot use this connection to find out the parity bits. This is nothing but the type of parity, either even parity or odd parity, right? हे समजलं का? इवन आणि ऑड पॅरिटी तुम्हाला समजलं का? राईट. नाव याच्यामध्ये काय प्रॉब्लेम आहे? मला नाही समजलं. तुम्हाला कोणा काय प्रॉब्लेम आहे? व्हॉट इज द प्रॉब्लेम हिअर? बोला.
ते सगळं समजलं मॅम, फक्त पॅरिटी बिट्स म्हणजे काय ते नाही समजलं.
पॅरिटी बीट म्हणजे काय? तुम्हाला आता तुमच्याकडे हा सिग्नल आहे 1 0 1 1, मी तुम्हाला मागाशी सांगितलं हा सिग्नल आहे, बरोबर. आता याच्यामध्ये एरर आहे की नाहीये, आणि असेल तर तो करेक्ट करायचा. यासाठी आपण एक्स्ट्रा बीट ऍड करतो, राईट. अँड दॅट एक्स्ट्रा बीट इज नथिंग बट पॅरिटी बीट, राईट. हॅमिंग कोड इज व्हॉट? इट इज जस्ट अन single bit error correcting code. Now this is what is the data you have, and if there is a error of single bit, okay, तर ते सिंगल बिटची एरर डिटेक्ट करायची आणि त्याला करेक्ट करायचं. फॉर दॅट वी आर गोइंग टू ऍड अन एक्स्ट्रा बीट to the original information, and that extra bit is nothing but your parity bit. लास्ट इयर डिजिटल मध्ये होतं ना हे सगळं, इव्हन पॅरिटी, ऑड पॅरिटी वगैरे वगैरे. मला वाटलं तुम्हाला आठवत असेल म्हणून मी स्किप केलं ते. आता समजलं का व्हॉट इज पॅरिटी?
हो.
Yes, ma'am.
हो.
नाव ठीक आहे. 4 + 3 4 मेसेज बिट्स बिकॉज वी हॅव डेटा 1011. हा डेटा तुम्हाला गिवन असतो ऑलरेडी 1011. 4 बिटचा डेटा आहे, सो दॅट यू विल कन्सिडर मेसेज बिट इक्वल टू 4. नाउ पॅरिटी बिट, you calculate how many number of parity bits we are going to add by using this formula. Parity bits we achieved is equal to 3. Everyone is clear till this? Just tell me.
Ma'am, 4च
Yes,
असतात
ma'am.
का?
नाही नाही,
जास्त
किती पण
नसतात ना?
बिटचा डेटा असेल. आय जस्ट टोल्ड यू ना, वी आर कन्सिडरिंग अ सिम्पल एक्झाम्पल, दॅट इज वाय वी कन्सिडर 4 बिट डेटा. 6 बिट डेटा पण आपण कन्सिडर केला होता आता, राईट?
Okay.
मेसेज बिट्स गिवन तुम्हाला किती पण असू शकतील. मोस्टली टू युअर लेवल मेसेज बिट्स आर 4 ओनली. 4 बिटच तुम्हाला एक्झाम्पल विचारलं तर.
Okay.
Okay, everyone is understanding till this 4 + 3, so 4 and 3, 4 message bits, 3 parity bits.
Yes, ma'am.
Yes,
Good.
ma'am.
Now next to that, see, the entire data which we are going to transmit is of 7 bits. Why 7? Because we have 4 message bits and we have 3 parity bits. 4 + 3 is equal to 7. That is why the entire data we are going to transmit is 1, 2, 3, 4, 5, 6 and 7. That is of 7 bit. ऑल राईट. आता त्या 7 बिट मध्ये पॅरिटी बिट नेमकं कुठे ऍड करायचं? करेक्ट. पॅरिटी बिट नेमकं कोणत्या पोझिशनला आपण ऍड करणार आहे? सो दॅट इज डिसाइडेड बाय द 2 पॉवर प्लेसेस. आता 2 पॉवर प्लेसेस म्हणजे काय? 2⁻0, 2⁻1, 2⁻2, 2⁻3 अँड सो ऑन. राईट. 2⁻0 is 1. That is why at this position we have 1. I will add my first parity bit. Correct. Here there is a 1. That is why I will add my first parity bit. 2⁻0 म्हणजे 1. 2 ची पॉवर आहे का 1? आहे. That is why I will add P1. Now 2⁻1 is equal to 2. So at this position I will add my second parity bit. Is the 3 is the number in the 2 power places?
No.
No. That is why we are not going to add our parity bit to this position. After that, there is, after 2⁻1, there is 2⁻2. 2⁻2 is 4. So 4 is the number which is in 2 power places. That is why I will add P3 here. समजतंय का? Why I added parity bits at this position only? 1, 2 आणि 4 लाच का parity bit ऍड केलं? दुसरीकडे का नाही केलं? हे समजलं का?
हो.
Yes, ma'am.
राईट. नाव 3 पॅरिटी बिट झाले, P1, P2, P3. उरलेलं काय असणार आहे तुमचं? मेसेज बिट M1, M2, M3, M4. 4 बिट डेटा होता की नाही आपल्याकडे? मेसेज 4 बिट आणि पॅरिटी 3 बिट. दॅट इज वाय इक्वल टू 7 बिट्स ऑफ डेटा वी आर गेटिंग. तर 4 मेसेज बिट्स तुमचे M1, M2, M3, M4. सगळ्यांना समजलं हे इथपर्यंत की नाही समजलं? परत सांगा
हो.
मला. सगळे, एव्हरीवन. आय वॉन्ट रिस्पॉन्स फ्रॉम ईच अँड एव्हरीवन. दिस इज अ सिम्पल थिंग. संदेश समजला का?
हो.
आता प्रत्येकाचं नाव घेऊन विचारू का मी तुम्हाला? बोला पटकन, समजलं की नाही? अंजू, गुणवंत, कुलदीप.
समजलं मॅम.
हो समजलं मॅम.
असं मी प्रत्येकाचे नाव घेत बसते, मग तुम्ही मला म्हणा समजलं आहे की नाही? Moving further, see, we get our total information that is of 7 bit. आता 7 bit काय इन्फॉर्मेशन आहे तुमची? P1, P2, M1, P3, M2, M3, M4. आता हा सिक्वेन्स कुठून आला? फ्रॉम हिअर ओनली. P1, P2, M1, P3, M2, M3, M4. हा सिक्वेन्स समजला इथपर्यंत सगळ्यांना? राईट.
हो,
सो
ma'am.
नेक्स्ट टू दॅट, व्हॉट वी आर गोइंग टू डू? we are going to actually start the process of generating Hamming code. Right? What we are going to do, we are going to start the process of actually generating Hamming code. Hamming code generation, important thing. इथून पुढचं तुम्हाला एक्झाम मध्ये लिहायचं आहे किंवा इथून पुढच्या स्टेप्स तुम्हाला एक्झाम मध्ये फॉलो करायच्या. द एंटायर थिंग विच वी डिस्कस्ड वॉज जस्ट अ बॅकग्राउंड थिंग. You should know all those things, right? But in exam you have to follow these things. See, for an example, 1110 is the message we want to transmit. आता आपल्याला मेसेज सिग्नल दिलेला आहे, मेसेज बिट इक्वल टू 1110. मेसेज बिट किती आहेत तुमचे? m is equal to
4.
4. So one thing is clear, m is equal to 4. Right? Now we have to find the number of parity bits. Number of parity bits. How to find number of parity bits?
2 raised to p is greater than equal to p plus m plus
1. Correct. So by using this formula, we are going to find number of parity bits, which we already find. We have 3 parity bits. Right? आपण मगाशी बघितलं, to satisfy this condition for 4-bit message signal, we have to take p is equal to 3. See, p is equal to 3 म्हणजे 2 raised to 3 किती?
8.
8. That should be always greater than or equal to p किती consider केला आपण? 3. So 3 plus 4 plus 1, how much it is?
8.
8. So here the condition is satisfying. 8 is equal to 8. Right? That is why we consider parity bit is equal to 3. Clear?
Yes.
Yes.
Right. So that is, we have 3 parity bits and 4 message bits. The total signal is of 7 bit. Right? After that, we are going to write bit positions 1, 2, 3, 4, 5, 6, 7. In that, wherever there is 2 power places, we are going to add our parity bit. 2 raised to 0, 2 raised to 1, 2 raised to 2. Why we are not considering 2 raised to 3? 2 raised to 3 का नाही घेतला आपण?
2 raised to 3 is 8.
Right, because 2 raised to 3 is 8 and we don't have bit position till 8. आपल्याकडे bit position maximum 7 पर्यंत आहे. 8 आहे का? नाहीये. That is why we are not considering bit position 2 raised to 3. Correct? आता हा sequence मिळाला. P1, P2, M1, P3, M2, M3, M4. Now here M1, M2, M3, M4 तुम्हाला माहिती आहे काय डेटा? 1, 1, 1, 0. So M1, 1, 1, 1, 0. Correct? See here, P1, P2 आपल्याला अजून माहित नाहीये. M1 माहिती आहे का? माहिती आहे. That is 1. P3 we are not aware of. M3, M2, M3, M4 1, 1, 1, 0. Everyone is clear till this? हे कसं मिळालं तुम्हाला हे? This is your 50% solution of your example. Example तुमचं 50% solve झालेलं आहे. Right? After comes the concept of even and odd parity, which I just explained. What is even parity and what is odd parity? If the number of ones is equal to even, then it is even parity. If the number of 1 is equal to odd, then it will be odd parity. Right? Less than 1 minute is left. पुढचं एक्झाम्पल थोडंच राहिलं हे लास्ट. हे होणार नाही एका मिनिटात. Right? We will explain, we will study this in next session. सगळ्यांना समजलंय का हॅमिंग कोड? लेट मी नो फर्स्ट. अर्ध झालंय आपलं, तेवढं समजलंय का?
Yes.
हो मॅम.
राईट. नेक्स्ट सेशन मध्ये तुम्हाला मी उरलेलं क्लिअर करते, जे काय असेल आपलं राहिलेलं एक्झाम्पल जे आहे ना, कारण लेस दॅन 1 मिनिट इज लेफ्ट, कधी पण लेक्चर एंड होऊ शकतं. ऑल राईट.